Fine, guys, let's start. Okay. So yesterday, yeah. So yesterday we were discussing about the covariance correlation concepts, right? So we have seen few things. So now to just show you, so this is positive, zero, negative correlation. Agree? So now just if I go through few points, yeah, positive correlation when the value of the variable deviate in same direction, when value of another variable decreases or increases, then the other variable depending. Okay, if both are increasing, decreasing, yeah, this we have seen. Positive examples are height and weight. Height increases, weight increases, amount of rainfall and crops yield. Okay, income and expenditure. Fine, if income increases, expenditure increases. Okay, like that we have lot of examples. Fine, and similarly negative is the different part. Fine, so zero is when they are independent of each other. Okay, and now correlation and causation are also not the same thing. Fine, I think till here we have seen, you remember, so we have seen till correlation and causation. Right? So if I show you now, if I just show you an example now, see here I'm considering a value set of values x 1 2 3 4 5 6 7 8 9. Okay, and y is exactly the opposite of this. Okay, that means if x is increasing, clearly you can say y is decreasing. Fine, and if x is decreasing, y is clearly increasing. So both of these are exactly opposite to each other. So these are what? These are negatively correlated. Fine. So now let's try to find that. So if this is negatively correlated, what is the range of correlation, guys? Can anyone of you tell me? Range of the correlation. No one? Okay. So yesterday we have discussed, right? Correlation range is from -1 to 1. Forgot?
Yes, sir, discussed.
Yeah. So correlation range is -1 to 1. -1 is for the negative correlation. +1 is for the positive correlation. 0 is a no correlation. Fine. So here you can see pointedly I'm taking exactly opposite number so that these are negatively correlated. Fine. If these are negatively correlated, what should be the value of these two? -1. Okay, so let's see that. Fine. So now we can clearly say that the data set x increases, y decreases, and vice versa. Fine. Let's also prove this with the formula. Fine. So now if you see what's the formula, you can yeah, you can do the formula for the correlation. Yeah, as we have seen, the formula for the correlation is this: each value minus x bar minus y bar square root of this so and so. Okay, so if I try to do the same thing, so these are my x values, these are my y values. Fine, this is my x minus x bar, this is my y minus y bar, x minus x bar whole square. Okay, y minus y bar whole square, x minus x bar into y minus, the same individual terms what all required in the formula I'm calculating independently. Okay, now correlation of this will be, if you put everything into the formula, you got -1. Okay, if you put everything in the formula, you will get -1. As expected, we got the perfect negative correlation between x and y. Getting, guys? So because x and y, I have deliberately took it as like opposite to each other. So when it's opposite to each other, obviously they are very strongly negatively correlated. So if it is strongly negatively correlated, the value should be -1, which we are getting over here. How the formula above I have shown. So just calculate all the independent terms and replace in the formula and calculate the expression. You will get -1. Is this clear, guys? Why this is -1? How we are proving it is negatively correlated?
Yes, sir.
Yes, sir.
Okay. So now if you see, as we proceed further, we will use several statistical tools such as Python statistical libraries, and etc. So if you noticed, yesterday we have used something called as SciPy, right? So this stands for scientific Python. So in Python, you have numpy, pandas. Just to give an overview, we have numpy, pandas, okay, and matplotlib, something called as matplotlib, cborn, okay, and then we have SciPy. Right? These are different packages for different purposes, guys. That's it. NumPy is what? Numerical Python, in numerical Python. Okay, these are for the, these packages has lot of tools which will help us to work on matrices, arrays, numbers, etc. Okay, NumPy. Pandas is mainly for the data frame accessing, manipulating different actions. Fine. To work on data frames, okay, on the data, actual data, is pandas. Now matplotlib and cborn, these are for the visualizations, okay, to visualize the data. Fine. So if this is x, how does it look like in the graph? Okay, so we have many more actually, but mainly we the famous one are matplotlib and cborn. In this, matplotlib is for the basic visualization, cborn will be little advanced. And now coming to SciPy, this is scientific Python. So this has lot, this is a package, right, which has lot of modules and functions and tools which will help us to work on statistics, statistical measures, fine, and etc. Fine. So these are the different packages. So we are going to study all this. Okay. So now yesterday we have seen SciPy, right? So that's the reason I have mentioned. So now, now if you see, we have done it manually. Okay, all this we have done it manually. But if you don't want to do this manually, no problem. We directly have some formula. Okay, in numpy, you have directly a function called as CORR COEF. Okay, correlation coefficient. You're able to see correlation coefficient. Okay, so yesterday, yeah. So from SciPy.stats, we have used Pearson. Okay. From SciPy.stats, we have used Pearson and we are able to get the correlation. That's fine from SciPy. But from the NumPy also you can do. Okay. From NumPy also you can do. And there is an added advantage of NumPy, which I'll be mentioning. Okay. So in NumPy, what happens? You need to just use from NumPy, import CORR COEF, correlation coefficient. Okay. Now passing X, passing Y. Okay. To this correlation coefficient, just pass X and Y. Okay. Now the output is this, Meghana. Observe here. Output is this. Now, what does this output mean? So if you see, it is saying 1 minus 1 minus 1 1. Clear? So now how, what does this mean is, see, we are having two values, X and Y. Now the way this is created is, if you are having X and Y, the table is should be read as like this. The table will be like this. Okay. So the correlation coefficient which you are, the correlation coefficient which you are seeing over here will be between X and Y, right? So you will be taking X and Y in the x-axis, on the y-axis also you will be taking X and Y, and this will be what? This, you have four things over here, 1 2 3 4, agree? So now one will be, one is what? Correlation between X and X. Okay, X comma X. Right? This will be what? X comma Y. Okay, this will be what? Y comma x, and this will be y comma y. Okay, now now as you can see, the diagonal part. Okay, this type of diagram you will see in many places also, but always remember here the diagonal. Okay, the one, this diagonal. Okay, this diagonal, as you can clearly see, it is considering with the same column. That means here you are checking, x with x. Okay, you're checking y with y. If you have one more z and z, for example, you'll have here z comma z. You are able to see, right? So you'll have xx, yy, z comma z. Fine. So clearly, this diagonal will be the correlation between same column. Okay. Now, obviously, a column with it with itself. What will be the correlation? 1. Every column, if you consider with itself, the correlation will be 1, because if that column increases, obviously it means that column increases. Okay, it sounds funny, but when you are checking a column x comma x, that means I'm checking a correlation of the column with itself. Obviously, it will be 1. Agree? Do you agree this, guys? A correlation of a column with itself will be 1 always. Okay, fine. So now here also correlation of y with itself will be 1. So diagonal values will always be 1. Okay, this will be 1, this will be 1. Now here, this is what? Correlation of x with respect to y, and here y with respect to x. So both will be same. Correlation of A and B is same as correlation of B and A. Okay. So now here, this value, what we got for this value? So this value will be -1. Okay. If this is -1, this will also be -1. Fine. So now why this is -1 we have seen. So the same thing which we have done, above, can calculate your -1, right? So similarly, when you pass these values to this function called as correlation coefficient, it will internally calculate what is the correlation coefficient between x and y. It is -1. Okay. So obviously y and x will also be -1. Y will be 1, x will be 1. So that's the reason. You have xx1, yy1, xy -1, yy, yx -1. So that is the matrix it is showing over here. Is this matrix clear, guys?
Yes, sir. Clear.
Okay, fine. So now we'll see another example. So if you see, you are having an array of 3 numbers. Okay, 0, 3, 4, 1, 2, 4, 3, 4, 5. Okay, some numbers we are having. Now if you pass, that means 3 set of numbers. You can call it as A, B, C. 3 set of numbers. So when you're saying 3 set of numbers, if you just pass, okay, as an array, all of these are x. Fine. You're just passing what is shape of x, 3 comma 3. That means what? 3 rows, 3 columns. And to the np dot correlation coefficient, if you pass x, that means what? You are passing A, B, C. So when you're passing A, B, C, the the advantage of using correlation coefficient is directly you can get the correlation of all possible combinations. Meghana. Fine. So but here if you see, here also you will get, but you will be able to find out the correlation coefficient, Pearson or Spearman. So but here you need to pass individually. Okay, to the Pearson you need to pass individually. You can loop through it and pass 2 at a time and get the correlation. That's fine. But before going to SciPy, if you just look at the numpy to this correlation coefficient, fine. If you pass set of values, okay, I'm passing 3 set of values, it will calculate the correlation coefficient of every possible combination. That means what? Simple. This is ABC, right? So ABC, it will create this table ABC, ABC. This will be, first one will be what? Correlation between A and A. Correlation between A and A will be what? 1. Simple. Now next, correlation of B and B, 1. Correlation of C and C, 1. Okay, correlation with itself will be 1. Now what is this? This is correlation of A and B. This is A and B. Agree? This is A and C. Okay, this is B and A. Okay, this is B and C. Agree? This is C and A. Okay, this is C and B. Okay, so now as you can see here, A and B, B and A both are same. Correct? A and C, C and A both are same. B and C, C and B both are same. So that's why if you observe here, this is 1. Okay, this is 1. After that, this value and this value will be same. See here, 0.891, exactly 0.891. Why? Because this is A and B and this is B and A. Both will be same. Fine. And this A and C and A will be same. As you can see, 0.9607, 0.9607. Fine. Why? This is A and C, this is C and A. Similarly, this is B and C, this is C and B. Both are same. Clear? So with this simple function, you can pass any number of list. So it will calculate all the possible combination correlations. Okay. So from this, can you tell me what are the most strongly correlated sets and least correlated sets, Meghna?
C and
Yeah, to help you, I just bring back the diagram. Yeah.
C and B
C and B is the
strongly correlated.
okay. And the least is
Least is A and B.
least is N. Perfect. Okay. So this is how you can calculate the correlation coefficients. Okay. Simple. You already have all predefined functions. You will have, just pass the values, and I think you are having now good understanding to how to interpret these values, right? So don't forget this range, -1 to +1. Okay, this is the range of correlation coefficient. Okay, in this diagram, whatever the values you take, even 100 list of values also you give, you will have what? 100 by 100. So if you observe, if you pass 3 values, this table shape will be 3 by 3. If you pass 10, it will be 10 by 10, 100, 100 by 100. So whatever be the values, the range of this will be always -1 to +1. So as you can see, it will not be greater than +1. So it will be maximum 0.98, 0.99, or it will be 1, but not greater than 1. Similarly, if it is negatively correlated, it will be -1, maximum. Okay, fine. So now in the above example, we are trying to find the correlation between 3 values. The matrix represents the correlation between them such that second value in the first row. Okay, I have explained it. So these are the different correlations. Okay, fine. So this is how you can find out the correlations for any two numbers. Fine. So yeah, you can just take some example. Okay, any data set you can take and convert them into list, convert each column into list, and pass them into correlation coefficient. Okay, so you can try this, and also you can also try this way also, Pearson coefficient way also. Okay, so now this is one concept which I need to cover. Second thing is, now we are going to, yeah, so now I'm going to start another concept which is called as, okay, which is called as frequencies. Okay, now see. Yeah, so looks like Siri disconnected. That's fine. Okay, that's fine, so don't worry about them, so they can cover through the recordings. Okay, fine. So now see, fundamentally in stats, okay, in stats, one of the most thing you need to understand is called as frequency distributions, Meghna. Okay, frequency distributions. Fine. So here, what does frequency distributions mean? So the other day I was showing you some diagram. Okay, I was showing you, if I remember. Yeah. So yeah. So these diagrams, if you remember, I was discussing about the symmetrical distribution, positive skew, negative skew, right? So this diagram. But if you think for a while, so how you will get this diagram? Okay, how you will get this diagram? Because if I in the correlation coefficient, I'm having some x and y. Okay, I'm having some x and y. So if you plot these x and y, I was always getting for any two variables either this or something like this. No correlation. Agree? Any value, any two values you plot, so you will get some diagram, some line you will get. But how you can get perfect bell curve shape? Okay, in which cases you will get this perfect bell shaped curve? What type of distribution that should be? Fine. So these are all called as frequency distributions. Okay, these are all called as frequency distributions. Fine. But what is frequency distribution? Let's try to understand that. Okay, so frequency distribution is very simple. Fine. It is just a chart, okay, that summarizes values and their frequency. Okay, it is just a chart that summarizes its values and their frequency. It's a very useful way to organize data if you have a list of numbers that represent the frequency of certain outcome in the sample. Okay, it's just simple. Here you will have, fundamentally, always remember this, Meghna, in frequency distribution. Okay, will be only just two things. One is you should consider some event. Okay, what is a distribution? You are talking about certain event, right? What is the event? Event could be anything. You want to calculate the heights of a person, you want to calculate the weights of a person, salary of a person, okay, or number of cinema theaters in a particular location, okay, or number of what a person number of tours a person can make in his lifetime. Okay, or any event you should consider. Fine. So in that event, okay, in the event, what you will have certain outcomes. Okay, you will have certain outcomes. Okay, and you will have probability for each outcome. Okay, or before going to probability, you can consider frequency for the outcome. Okay, in frequency distribution for any given event, you need to calculate two things. One is outcome, and what is the frequency of each outcome. Okay, frequency of each outcome. Getting tell me. Frequency distribution is any event you will have an outcome and frequency of each outcome. Okay, now just to give you an idea, this type of diagram which you have seen here, okay, which you have seen here, see, for example, if I take, so this is called a normal distribution, right? Symmetrical distribution. If you remember, I also mentioned one of the type of symmetrical distribution is what? Normal distribution. Do you agree? We have
Yeah.
normal distribution we have seen. Now this is a normal distribution, but how does this looks like? Okay, so for example, when I come to normal distribution, I will again speak this in detail, but just to give an idea, okay, just to give an idea, most of the real life events, right, they follow normal distribution. Right. Now what does that mean? For example, if you take a height of a person, okay, heights of people, okay, so now this is a height, Event is what? Height. Now, what are the outcomes of the height? Outcomes of the height will be anything. Okay, it will be like, for simplicity, 4, 4.5, 5, 5.5, okay, 6, 6.5 maximum. Okay, these are the outputs. Okay, so if I want to draw, a graph, okay, if I want to draw a graph between age, okay, age and height, okay, age and height, okay. Usually in age, what do we have? You can have like 0, 10, 20, 30, 40, 50, something like that. Okay, usually the, if you see from 8 to 0 to 10, what will be the maximum height? 0 to 10, the height will be little low. Agree? 0 to 10, for all the people who are whose age is 0 to 10, the height might be something like this. Okay, just let's say how much, 3 inches, 3 or some 3 inches they might be. From 10 to 20, the height might be little more. Agree? From 20 to 30, it might be peak height. Okay, just as an example. After 30, no growth. And 30 to 40 people, slowly height will not decrease. Okay, but height, I'm not saying height will decrease, but there might be slightly bend. Okay, and the old age people, the height might be little less. Okay, so now if you try to join these, okay, if you try to join these, you will see a bell curve. So what did we plot here? The age, okay, and its height. Okay, here we have considered height and its corresponding frequency. That means from 0 to 10, how many people are falling? That is a frequency. From 10 to 20, how many people are falling? That is a frequency. Agree? Similarly, if you take salary, okay, if at all, if you take salary example, even salary also, um, yeah. So if you take salary, initially 0 to 10 age, there will be zero salary. 10 to 20, if you're doing part-time job, bit salary. 20 to 30, you might have good salary. 30 to 40, peak salary. For again, 30 to 35. Okay, again, if you, as you become old, the salary will decrease. Okay, fine. So now, as you can clearly see, salary and its frequency. That means in each bucket, okay, from 10 to 20, 20 to 30, 30 to 40, what is its frequency? Okay, so if you calculate that, this will also follow a graph. Fine. So like this, there will be many events in real life, okay, which will almost follow this particular graph. Okay, so I'm just giving an introduction. Fine. So but this graph is also called as frequency distribution graph. Okay, this is also called as frequency distribution graph. Okay, we'll come back here. So now, as you can see, as I said, frequency distribution is outcome and its frequency for each outcome. Okay, fine. So now, first of all, there will be, yeah, first of all, there will be two types of numbers, two types of values, right? In the first class, if you remember, I was mentioning what type of numbers you can have, what type of data. If I speak about data, categorical, numerical. Remember?
Yes, sir.
Categorical, numerical. If you remember, in numerical we also have discrete and continuous. Okay, that's fine, but let's not get into this as of now. Okay, at high level you have categorical and numerical. Fine. So this is the reason why we studied this is, you'll understand now. Okay, so now actually this, from this, right, so you are actually like entering, I can say, the actual stats. Okay, so till now we have considered like small concepts like mean, median, deviation, symmetric, asymmetric, covariance. Okay, that's fine, but from here actually this is the actual stats. Now in here, first thing you should understand here is frequency. Fine. So frequency is simply outcome and its frequency for each outcome. Okay. Now this we can do it for two types of data: categorical data, numerical data. Now for categorical data, what happens we'll see. Okay. So now for the categorical data, if you see, okay, see, as you can see, first of all, if I take what is categorical data, it will have just few categories. This will have few categories. Okay. So here, as you can see, what are the categories I'm having? Beach, city, adventure, nature, cruise, other. What is this type of vacation? So how many categories I'm having? Six categories. Okay. How many categories I'm having? Six categories. And how many people are liking beach is this. Okay. This is the frequency. Okay. This is a type of vacation. This is a categorical. This is an event. Okay. Or you can call this is the outcome of this event. What is my event? Type of vacation is my event. What are the outcomes of my event? These. Okay. Beach, city, adventure, nature, cruise, other. Okay. And what is the frequency of each output or each outcome? This. Okay. This is the frequency. That means how many people are liking beach? 60. How many people are liking city? 40. Like that. This is frequency. Getting any doubts here? The outcome and the frequency part?
No, sir, no doubts.
Okay, fine. So now here you will be having three things, Meghna. One is frequency, one is relative frequency, one is cumulative frequency. Okay, three things we will be studying. Okay, but these are very, very simple. Frequency is the actual frequency. How many times this particular value is repeating. Okay, now what is relative frequency? See, if I try to sum all this, okay, so no, relative frequency is, so let me take a calculator. The overall sum of these values is 200. Okay, what is the relative frequency of beach? 60 by 200, 0.3. Okay, relative frequency is like, you can call it as like not exactly probability, but what is its relative among all. Okay, when compared to all other, what is its share? Okay, as you can see clearly, overall frequency is 60, but if you calculate in the percentages sort of thing, okay, so its share is 0.3. Agree? So similarly for 40, so overall sum is 200. Okay, just the value by overall. Okay, value by overall is 200, 0.2. Okay, but let me call for nature. Okay, nature 35 by 200. Okay, 0.175. Getting relative frequency? It is
Yes, sir, understood.
it is just what's the value by sum. Okay, sum is 200. Sum is 200. Okay, so relative frequency is what is its portion. Okay, what is its contribution in the overall value. Okay, but now you have one more thing called as cumulative frequency, Meghna. Cumulative frequency is very simple. If you see for beach it is 60. Okay, so let me erase this. Okay, see, notice here for cumulative frequency for beach it will be 60. For city it will be beach plus city, 60 plus 40, 100. For adventure, cumulative frequency will be beach plus city plus adventure. Okay, that means what? 60 plus 40 plus 30, 130. Agree? For nature, it will be nature and all above it, 165. For cruise and all above it, 185. For other, all. The sum, the overall sum which you have seen 200 is 200. Clear? This is the actual frequency. This is just the relative frequency. This is a cumulative frequency. Actual frequency is just the frequency of all the outcomes. Relative frequency is its percentage in the given overall values. Cumulative frequency is just the cumulative sum of that event and all the events that has occurred before it. Okay, so if you consider these events, okay, if you consider these as events, okay, these are the outcomes. For example, if these are the outcomes of an event called as type of vacation, cumulative frequency of particular outcome will be its frequency and also sum of all the outcomes that has occurred before this. As you can see in this order, for adventure, city and beach has already occurred before it. So the cumulative frequency of adventure will be 30 plus all occurred before it. That means 30 plus 40 plus 60, 130. Okay, cumulative. That's why it's called cumulative. The English word cumulative is what? Group, all together, combining everything. Okay, so for nature plus all that has occurred before it, all this 165. Fine, that is cumulative. Let me know. Did you understand frequency, rate of frequency, cumulative frequency?
Yes, sir, understood.
Okay, simple. So now if this is for categorical data, okay, but now coming to numerical data, okay, we have this, okay, but here there is very one important thing to understand, Meghna. Just think, what did I say? I said frequency. Oh, I said outcome and its frequency, right? So I said for any event you will have two things: outcome and frequency of each outcome. Agree? Frequency of each outcome. Here also outcome, frequency of each outcome. Simple. This is for categorical. Okay. But for numerical, what happens? Coming to numerical, any numerical example if you take, okay. For example, in the case of height, okay. For example, in the case of height, if I take, if you take 100 people, the heights of 100 people will be all different. If we calculate at the decimal value, okay, one guy height will be 4.9.92, other guy height might be 5.64, okay, other height might be 5.642. Okay, these are different. So in a outcome where the output is numeric value, okay, here the output is categorical, just categorical. That means what? Whatever be the record, it should choose between these categories only. It should be one of these. Okay, you have total 200 people. Okay, all these 200 people, they should choose any one of these. Just 6 possible outcomes we are having. Okay, that's why 60 went here, 35 went here, etc. Okay, but the total possible outcomes are what? Just 6. That's why it's called categorical. These are categories. But coming to outcome where the output is numeric in nature. Okay, height, it could be height or it could be salary. Fine. So if I want to calculate the frequency distribution of salary, first of all, I should know what are the possible outcomes. Simple. For any event, if I want to know its frequency distribution, first thing I should know what will be the outcome of that event and what are the frequency of each outcome. Simple. Even now coming to salary, if salary is my event, fine. First of all, I should know what are the possible outcomes of salary and then frequency of each outcome. Getting? So, but for the salary, what will be the possible outcomes of salary, Meghna? Okay, even if I have a range of, let's say in a company, the starting salary is 25,000 and the maximum salary is 10 lakhs. Okay, what could be the range of salaries?
25,000 to 10 lakhs in between
Correct.
values.
What will the what could be the possible outcomes?
Anything may come.
Correct. So anything might come. Agree. So from this, anything is possible. Okay, if you have like 10,000 people, okay, if you have 10,000 people, okay, just like here I'm 200 people, right? So if you have 10k people, each person's salary might be different from other person. Okay, if you calculate the complete amount, okay, one guy's salary might be 30,554, other guy might be 40,634 dot something. Okay, like that, if you calculate, you can have 10,000 different values. Agree? So in this case, what's happening? In this case, what's happening? The outcomes are what? Now here in numeric scenario, okay, in numeric scenario, the here also you need two things. One is outcome and frequency of each outcome. Frequency of each outcome. Fine. But the outcome, what are the possible outcomes? Possible outcomes are 10,000. No, sorry, not 10,000. Possible outcomes are infinity. Almost infinity, you can say. Okay. Possible outcomes are infinite because the range is from 25k to, if you take ranges from 25,000 to 10 lakhs. What are the possible outcomes? It could be anything. Almost it could close to infinity. Agree? So obviously you cannot calculate the frequency of each value. Getting? Trying to understand the problem we are facing here in numeric data. Since the outcome could be anything, the range is almost infinite, right? So we want two things for frequency distribution table. One should be outcome and frequency of outcome. So here, if you calculate, try to understand the number of outcomes, it is almost close to infinity. Okay, and even for example, even if it is not infinity, okay, just think, Meghana, even if it is not infinity, even for example, uh, if you consider only integer values, okay, not decimal values, okay, integer values, then how many values you might get? In 10 lakhs you will have 10 lakh values. Agree? And here one more 75,000, so 1 lakh 1.75 lakh values are possible. Okay, if you consider only decimal values, like only 1 2 3 4, like that, not considering the decimal values, only integer values. Fine. So from 1 lakh to 10 lakh you will have 10 lakh values. Okay, and here 75, so 10 lakh 75, okay, 10.75. Understood this? 10.75 values you will have. Okay, so even in this 10.75 values, you can at least, if you think, okay, my outcome is having how many values? 10 lakhs values. Okay, just for simplicity, let's say 10 lakh values you are having, 10 lakh output values. In this 10 lakh values outcome, we need to calculate what frequency of each outcome. That will be almost 1, because if you are considering the complete value, mostly the salary might not repeat, right? It might be the exactly one time the salary might occur. Agree? So one guy's salary might be, as I said, 26,484. Okay, other guys might be 56,722, something like that. Okay, so what is the frequency of outcomes now? Can you tell me what is the frequency of outcomes now?
Means range as a what?
Hmm? No. See, if you consider 10 lakhs, from 10 lakhs discount, almost you will have all different salaries together. You will have all different salaries. Okay, mostly the salary will not repeat. Fine. So if you have all these 10 values, now what will be the frequency of each value?
Maybe 1.
Right, 1, because frequency is what? Number of times it's repeating. Okay, so the frequency will be 1. Fine. So if you take 10 lakhs, the frequency will be 10 times. Okay, obviously this is not helpful. Fine. So if you have 10 lakhs you are finding, but what if you have, but actual the value might be anything. Even if you consider heights also, from starting 4 feet to maximum 6 feet, if you consider, in this, between these two also, you can have infinity value of possible outcomes. Fine. Infinite values are possible. And if you take the probability, obviously you will get mostly 1. If you consider to the decimal point, you will consider 1. Okay. So considering this way is not helpful for numeric values. Getting? So this way, if you approach, so it is not helpful to find out any distribution because of the wide range, okay, in the numerical part. So that's why what we will do, we will try to bins. Okay, now bins is very important thing which you are seeing. Bins is what? It is just nothing but we are grouping. Okay, we are grouping or we are putting into buckets. Okay, we are grouping or we are just putting into buckets. Okay, that means what? That means what? So we will consider 6.4 to 6, right? 4 to 6. So we'll say, hey, from 4 to 4.5, one group, one bin. Okay, first bin. Okay, 4.5 to 5, second bin. 5 to 5.5. Okay, third bin. 5.5 to 6, fourth bin. Agree, Meghna? Initially, if you consider like this, there are infinite values are possible from 4 to 6, and we cannot calculate the probability of everything. But here, if you consider bins, this infinity got reduced to 4. That means any person whose weight is between 4 to 4.5 will be considered as first bin or interval or group or bucket. Okay, usually we call them as bins. Fine. So any person whose height is between 4.5 to 5, second bin. Any person 5 to 5.5, third bin. 5.5 to 5, 6, fourth bin. Okay. Similarly for the salaries also. So now you will have indirectly we are converting into categorical data if you understand. Getting? So in categorical data also we have some fixed number of categories. Fine. So we are trying to convert to the similar structure. So even in the salary example also, since from, let's say, even if you consider from 1 lakh starting 1 lakh and maximum 10 lakhs, there are infinite number of values possible. So obviously we cannot do distribution for those, frequency distributions for those. So what we'll do, we will try with some bins. That means what? From 1 lakh to 2.5 lakh. Okay, I'll consider first bin. 2.5 to 4. Fine. 4 to 6.5. Okay, 6.5 to 8. Okay, 8 to 10. Fine. So instead of considering infinite values, I'll just consider 5 bins. 5 bins. That's it. So now what? Even in the company, if you're having like 10 lakh people, 10 lakhs people, okay, for example, 10,000 people, 10,000 people, each salary I can check and see which bin he is falling into. Agree? I can accordingly put each person into one of these 5 bins. Simply I can do that. Then I will get some count. This 10,000 might get converted into like what? 3,000 might go here, 3K might go here, some 2K might go here, 2K might go here, 2K might go here. How many left? 1K might go here, for example. Getting? So this 10,000 salaries, whose salary is between 1 lakh to 10 lakh. Fine. So for numerical data, we will use the concept of bins. That means what? We will create the overall range, whatever the possible outcomes which you are having, we will convert them into bins. Okay. See, 5 bins I considered, and all these 10,000 people I am putting into the respective bins. Fine. Now this what? The possible outcomes are not infinite. What are the possible outcomes now? Just 5. Getting? The possible outcomes are now just 5. What are these 5? First bin, second bin, third bin, fourth bin, fifth bin. Okay, any value you give, it will be falling in one of these bin. And to each bin, I'll have some frequency. Now you have the interval and you have its corresponding frequency. You can draw frequency distribution. You can understand frequency distribution, right? So from infinite possible outcomes, using bins, we have converted into 5 bins. Is this clear, Meghna? Are you able to follow?
Yes, sir.
Okay, fine. So once we have this, so that's why always remember for numerical data, we will always use the concept of bins, because any numerical data, height you take, weight you take, okay, salary you take, okay, or similarly anything, house price, Okay, house price you take. Okay, any numerical data if you take, obviously infinite number of values are possible, right? Simple, infinite number of values are possible for any numerical value. So obviously you cannot sit and calculate the probability distribution of every value, right? So that's why we will try to bin the numerical values. Okay, so here also if you see, class interval. Okay, so here this is some event. Okay, we don't know what is this event, but it is a numerical data. So since we cannot do it for each and every value, so that's why this guy has binned it. Okay, first bin, second bin, okay, third bin, fourth bin, fifth bin. Okay, different bins, 67 to 79. In this bin, how many people are falling? 3 people. This is what frequency: 3, 5, 8, 9, 5. Overall 30. Okay, overall 30 people falling into 5 different bins. Clear? Here overall 200 people falling into 6 different bins. Similarly 30 people falling into 5 different bins. This is possible only we are able to bin the values. Right, Meghna? For categorical data, there is no need of binning because these are already few numbers. But for numerical data, the outcome is extremely large. That's why we should definitely bin this. Okay. So now if you see same thing, what we are able to calculate over here, why we are doing actually this? Because to calculate frequency, relative frequency, cumulative frequency. Okay. So now if you see the frequencies we get, okay. So we get from the data, how many people are falling into each bin. Okay. I hope you can understand frequency. Relative frequency is what? Relative frequency is simple. So as we have seen, relative frequency is what? What is a percentage of this? 3, okay? 3 divided by whole number 30. 0.1 or 10%. 0.1 or 10%. Can you see here 0.1 or 10%? What is 5?
Yes, sir.
For 5, what is? So simply 5 by overall value 30. 0.16 or 16.7. 16.7. Clear? So similarly, you can calculate for all other values. Okay, so these are the relative frequencies of each value. So for 67 to 79, the relative frequency is this. Now coming to cumulative frequency, as we have seen here, cumulative frequency is the value and all the outcome and all the outcomes occurred before that. Okay, so here if you see for 67 to 79, cumulative frequency is 3. Simple. But for 79 to 91, what is the cumulative frequency? 5 and also 5 plus 3, 8. Getting? For 8, it will be 8 plus all the above. That means 8 plus 8, 16. For 9, 9 plus 16, 25. For this one, 5 plus 25, 30. Getting at last you will get the total count here. Whatever you are getting over here, you will get here. Okay, but cumulative frequency is just its outcome plus all its before outcomes. Simple. Fine. And for cumulative frequency also you can calculate the percentage form, that is cumulative relative frequency. Simple. For 3 it will be 10. Okay, so as you can see, how you are getting this 8, Meghana? This is 5 plus 3, right? 5 plus 3 is 8. Similarly, related to cumulative frequency also, you can do 16.7 plus 10, 26.7. Clear? This normal cumulative frequency is what? For 91 to 103, if you calculate normal cumulative frequency, it is this value plus all its before values. 8 plus 5 plus 3. How much it is? 16. Agree? That is cumulative frequency. Now, similarly, what is cumulative relative frequency? Adding all the relative frequencies, 26.7 plus 16.7 plus 10. That means what? 53.3. Agree? Similarly, for cumulative relative frequency, at the end you will have the total count. The end value will be total count, because why? This value plus all the values occurring above. So all the values occurring above means what? Complete value, that will be 30. If you calculate percentage wise, that means what? Here you are calculating complete percentage, that means 100%. That's why if you see here at the end, you will have 1 or 100% is a cumulative frequency. That means sum. Cumulative is sum of total. That and all before that. At the last, if you're considering this and all the above percentage, that should be 100. Clear? So this is the for the cumulative frequency of numerical data. Both for both numerical or categorical, it will be the same concept, Meghna. Okay, so it will be the frequency. For here also you can calculate cumulative relative frequency. Okay, here they did not calculate, but here also you can simply calculate relative frequency, cumulative relative frequency for categorical also. Fine. So this is what the frequency will be. The relative frequency will be cumulative frequency and cumulative relative frequency. Same thing for this. The only difference, only new concept you need to remember over here is for categorical, you already have the predefined categories. Okay, but for numerical data, since the outcomes are like infinitely possible, you will try to just bin them into different bins. And then once you bin them into different bins, obviously they almost sort of convert into categorical data, like few categories or few bins. And then you will have the frequency. Once you have frequency, it's done. Simply you can go from relative, cumulative frequency, or anything you can go from. Clear?
Yes, sir.
Fine. So yeah, so I would say that's all for today. So is the class clear, Meghna? So are you able to understand concepts or any confusions you have, or is it you are able to digest these concepts?
Yes, sir. Understood. It is clear.
Okay, cool. So fine. So tomorrow we are going to see like what type of graphs if given a one column, right? So if given a column, we'll see some distributions, like how to understand these graphs, and we are going to see few famous graphs like histogram, bar graph, scatter plot, okay, etc. We'll try to see visualize something, and then we will see bivariate. That means till now we are considering only one column, right? So what if you have two columns, okay, the same thing. So if you observe till now, initially we have discussed what mean, okay, then we have discussed median, then what standard deviation. What are these are all for only one column, one single column. Once we understood this, then we studied what covariance and correlation. This is for what, two columns, right? So for one, in this also we are using the mean concept only, okay, but to understand this, first we understood mean, and then we try to understand if at all we are having two columns, what is the relation between this column and this column. Fine. So that is a correlation. But in the correlation also, if you see the formula is having x minus x bar, y minus y bar. Okay, what is this x bar coming from? Y minus y bar coming from? This mean only. Fine. So first we'll study one column and we'll extend it to two columns. Similarly, here also we have understood for single column, categorical, single column, numerical. After that, tomorrow in bivariate analysis, if you see here, okay, here we will be understanding the combinations. Fine. So if it is numerical and numerical, what it will be? Categorical and categorical, what it will be? Numerical and categorical, numerical, what it will be? Okay, that will come under bivariate analysis. Okay, fine. So yeah, that's all for today. So we can meet tomorrow. Okay, cool. Thanks.
Thank you, sir.